Good morning, all. It's a beautiful Saturday, and hope you're all enjoying this Saturday. Some may be at work and some at home. However, I would like to talk about the Ask webinar series, the first webinar that we had last Saturday on 15th December. We had a session with Tanmay Bakshi. We had Malay Kannan from AI Sama Research. He is VP of AI Sama Research, and also Sivakumar Palaniappan, who is the leadership coach. It was a great 1 hour discussion we had, and unfortunately, we were not able to send the link to many of the registered participants. We had around 90 participants registered for the event, and we couldn't send that due to a glitch in the Google Form. However, we had an open link that was posted in the link, so we had good number of participants attended the webinar, and it was a very good 1 to 1 hour and 15 minutes of discussion that happened. The discussion was around the different roles in data science. What do you need to become? What do you need to learn to become a data scientist for whoever aspiring to become a data scientist, and also who are looking for a career change? What is the expectation at the industry level, and also at the what to learn to move into this field. Apart from that, there was also discussion around the mathematics, which is a quite discussion that is going on. Do we really need mathematics to do artificial intelligence due to the lot of applications around the algorithms are coming out, like AutoML. So there was a discussion around AutoML, and it was a very good discussion. There are many things that was done in the discussion. It was a very interactive, very interesting, and we are looking forward to continue this webinar series every month. We had one last week, and January we are planning one. We are planning with SRK and Mr. Aravind from CTS. So we will bring different speakers from different areas, different domain for this webinar series. Please follow the LinkedIn and see and try to register. It's only 100 seats with using Zoom. So it's a first come first serve. So please register and enjoy the webinar series. For the one who missed the last webinar, we have a recording, and following this, you can enjoy the discussion that we had last Saturday. Thank you. So, Malay, what do you see how this AI is going? So, I read a lot of articles. There are a lot of articles going on around this AI, and many research surveys by McKinsey and some analytics Vidya, and also many market researchers. If you read those articles, many are saying AI is getting into the enterprises, it is picking forward, it is moving on. But also at the same time, I also see few articles saying it is still a hype, and it is not there yet. The businesses are not seeing the revenue on what the AI is, on the application of AI. So where do we stand actually?
Okay, so the way I would put it is, right, like, so there is a lot of applications for AI in business sector. Okay, it's all the matter of actually choosing the right use cases for the right problems, right? The way, I mean, like, one way to put it is like, hey, like, we have always made decisions using analytics, right? Analytics using, like, what business intelligence reports, like, dashboards and all those things, right? Whenever you do that, like, what you generally do is you do a 2-dimension, or in case, like, some good ones, actually we go for 3-dimension, right? What we are really doing in those cases is we are summarizing for decision making. Okay, the more and more, the higher level it goes up in the organization, like, you start summarizing. With AI or machine learning, what happens is you start making decisions, like, with multi-dimensions, like, taken into consideration, and decision making is at the individual or detail level. You'll be able to split it up. You could roll it up if you want to, right? So again, that perspective has to be conveyed. It's not a magic bullet, right? It will not solve every problem, any problem that is out there, right? So every organization should have like, maybe sort of an innovation team to actually take this and run with it. Like, that's the structure what we follow even at Sama, and I've seen that in multiple clients where we engage in, right? We generally have an innovation team, and like, with whom we engage in, or an innovation program, and generally that team seems to be the risk-taking team, right? And the construct is also very narrow. You have to narrow the construct down in such a way that, hey, like, no, it's not going to, you don't boil the ocean. Okay. You limit it to one problem. You define what the outcome should be. You should know what is success and what is failure, right? On that particular thing. And you should actually enable the business leaders to actually engage even at the beginning of things. It's not like purely a research team, like, a bunch of mathematicians and programmers sitting and doing things in the background. It should not be that way. Like, active conversation should be engaged with business teams, right? The ideal pod, I call it pod for a reason, right? Like, ideal pod for executing something would be, like, there'll be a data analyst in that particular team. There'll be a business analyst in that particular team, a machine learning engineer or a data scientist, somebody of that nature would be in that team, right? And a visualization guy also would be in that particular team. So that's the way this pods have to be structured. And this is a good enough pod to conduct an experiment, right? To actually define whether its outcome is success or not. Okay. So sometimes what happens is, right, like, they expect a lot. Again, certain things to do with press too, right? I think it's actually has to do with the term neural networks. Okay. That's what I blame it on, right? Like, if you call it differentiable programming, I don't think this hype would be there, right? And again, due to that aspect, right, people expect a lot. They expect it to behave like maybe like a 10-year-old or a 12-year-old, right? We are not at that stage yet, right? But there's certain problems, even with the limitations, there are problems. If you choose it well, you could actually execute it better. Okay. Traditional problems which cannot, I usually give this example for people to explain about where you could actually apply machine learning or AI to solve the problem. The example about me running, right? Where, like, if I have to decide whether I have to run or not, like, I have like 10 variables that I have to look at, right? Like, whether it's raining or not, like, whether I have to drop my son in school, like, is it a weekday or a weekend? Like, is it like, how hot it is, like, what time of the day it is, like, all these variables, right? So traditionally, if I want to solve this problem, I will write, like, if else kind of programming. I mean, any programming language, doesn't matter whether it's functional or like procedural or object oriented, you could break it down that way, right? So if and else, right, like, if I start putting permutation combinations for this particular thing in with a truth table, the amount of permutation combinations that you come up with is quite a lot, right? So for 10 conditions or 10 variables, you end up with like so many, right? Like, but think of, like, there are scenarios where you would have 200 variables. Okay. That becomes an issue, right? So in those cases, that's where, like, machine learning can be applied, right? If you define your problem where, like, this is a binary outcome, right? Yes or no, should I run or not, right? Or maybe, like, at what time should I run? You could put it that way, right? For a prediction perspective. But if you define your problem well, then, like, there are a lot of applications for AI in business. That's the way I would put it. Sorry for the long monologue.
No. That's good, because we are doing few projects, and we are interacting with the business on projects, and we also do understand the thinking. What the business is having is, they think artificial intelligence and machine learning as the yet another software development program. So there is the education is not there, the awareness is not there. If there is no good data coming in, if they miss something in the data cleaning and pre-processing part, and if no good data is given in, then we cannot change in between. So they don't understand that we have to change the entire model, training model. We have to train again and all those things. They're not able to understand that. So it's very difficult for when we go for projects, very difficult to make them understand. Give clean data. You have to work on it. If you are changing your requirements in between the projects, then it may take longer time, because sometimes we have to start from the scratch again to train the model, build the model, and everything. So the education part is not there, and slowly they are coming in. They're trying to understand what it is. So I think at the executive level, at the business managers level, their understanding about the AI should be there. So this is what I see from my experience from the interaction with the business. And I agree with you, Malai. So there should be an understanding going on. But at the same time, I would like to ask Tanmay, because Tanmay has huge interaction with a lot of CEOs and founders, and to all levels. And Malai, you are also in research, and Tanmay is also in research. And so research is something in the deeper side, but when translating a research to a business is another part. So I should ask Tanmay, so what do you feel and what do you think What do you hear from when you meet with people, particularly with the businesses? We will come into what the students and the aspirants are looking for, but let's think what businesses are talking about. What do you feel in your perspective, where we stand right now?
Sure. So what I will say, sort of to expand on what Malai was mentioning and what you're saying, is that indeed, in fact, I actually had an entire talk on this in India at NASCOM on whether machine learning and AI is really just hype, whether it's real, whether it's fake. In fact, the title of the talk was real news. Oh, sorry. I guess good news, bad news, or fake news. That was the title of the talk. And so it's basically talking about what machine learning means for businesses and whether or not it's really all it's hyped up to be out there. And what I will say is that a lot of people expect more from machine learning technology than they can. Machine learning technology, as Malai mentioned, is not something that can be applied really everywhere people think it can. So whenever I go to different companies, like for example, I was at a few IBM partners in Amsterdam, and they always talk about how they have so much data they want to garner insight from using machine learning. But I do realize that there is a huge sort of disconnect in a way from the executives and the people that have, sort of over sort of the sight of what the company itself is doing and the data they're collecting, and the developers and the machine learning experts that are actually there that understand what the technology can do. So whenever I go to these companies or, talk to the CEOs, founders, and talk to them about where machine learning can help, the first step is always to have a better connect from the executives themselves to the developers to make sure that they can collaborate and understand this is what the technology is capable of, this is where we're gathering data, and this is how we can actually make that data useful. Like, just for example, if you take a look at Woodside Energy in Australia and New Zealand, what they were able to do is they were able to take all the documentation that they've created from their engineers, they were able to take what their engineers do on a daily basis, really, and as they do it, they were able to teach Watson what it is their engineers do in order to train newer engineers that join Woodside Energy to help them get on board faster. And so if it weren't for the wonderful connection between the actual developers at IBM and the machine learning engineers at IBM, alongside working with the executives at Woodside, that would not have been possible because the IBM developers wouldn't have had a good sort of, they wouldn't have had insight into what exactly it was that Woodside was doing or where they have problems, and Woodside wouldn't have an idea of where machine learning technology truly is applicable. So I will say that there is a little bit of a disconnect there. That's something that does need to be fixed. Malai did mention that people expect more from machine learning than they can right now. And people also sort of misunderstand what it is that machine learning can do in the first place. Really, it's about trying to, in a way, sort of what it allows computers to do in a unique way is understand unstructured data at scale, is one thing that I like to put it as. Whether it be structured or unstructured data with machine learning, you can garner further insight, but unstructured data is where machine learning really shines because that's the sort of unique ability that machine learning brings to the table that you couldn't have done before with rule-based systems, right? So as Lyle was mentioning, you could have if-else statements for tons of things, but when it comes to things like understanding visual data or natural language or auditory data, you simply cannot use those kinds of structured conditions because, well, it's way too complex. So it is very, very applicable. There are lots of cases where it's been applied. In fact, everything we do, even this webinar, is in some way using machine learning technology. If I'm talking to you on Zoom or on an iPad, it's using machine learning to help my voice come to you in a more clear way. So all of this is being powered by machine learning. There are tons of different places it can be useful, but there is a disconnect between the people who actually make the decisions and the people who actually develop the technology.
That's a very good, very crisp, I should say. You can still talk for hours, but it's a very crisp explanation what you can give. And now I would like to go to Siva. Siva Kumar Palniappan is the professional speaker, and he is also a leadership coach who mainly interact with students in tier 2 regions. Now he is going global and he has office in Singapore. Now he is giving speeches in Singapore and in developing nations. So I would like to ask Siva on this aspect. So what do you think, where do we stand in artificial intelligence and machine learning? What do you think when you speak to people, Siva? or students, what do you think? Where is the awareness? What do you think? I heard once you're saying in a huge 700, 800 students, but that you were saying that they don't know about Alexa in certain group, right? So Alexa is mainly machine learning and artificial intelligence. So where can you shed some what do you think, and what is the advice you can give to the aspirants who are thinking of getting into this? Shiva, I think you are mute.
I'm sorry. Yeah.
Oh,
Can you hear me?
yeah, yes, please.
See, what I understand while meeting a lot of young students across is most of them, especially in India, in our academic system, are still stuck with very old syllabus and the content that they learn in their academic institutions. And the academic system by itself is not developed, or they don't have an understanding and awareness about the latest trends and technologies. Though they listen and hear about these buzzwords, AI, ML, NLP, and things like that, they've heard about these words, but they don't really go deep down, understand, study, learn, and then kind of help students also learn the whole thing. That's when I addressed a huge crowd of students, people weren't even knowing Alexa, Watson. They're not knowing what all these platforms are actually in reality. But they also understand that AI is going to be a big revolution in the future. And I keep talking about this to students. For example, last year Gartner in their annual research conclave at a conference, they started the conference by kind of releasing the research they had done on AI and the future of AI. And they said 1.8 million jobs across the globe will be kind of displaced by artificial intelligence. At the same time, 2.8 million jobs will be created by AI platforms. The technology like machine learning or AI is going to create a lot of jobs, and they said this is the right time for a young professional, a technology guy to really get into jobs in those domains. But unfortunately, I see people still think AI or ML is a too advanced technology for them. It is too high from their standards, and they really don't want to kind of get on to the whole process, right? That's a kind of mind block or mental block I see when I go talk to students. They say, "Oh, it's very advanced. I don't think I can go learn that. I think it's all done only in the researchers. It's all done in the Western developed countries. I'm still stuck with Python and C++ is what I do actually." So that's where the big challenge is: the mental block and the mindset thinking that this is too way high for me to learn access is a very big mental block. And in fact, I even talk about Tanmay when I go talk to students, how Tanmay is kind of breaking through, becoming a global personality in the technology at a very young age. If Tanmay can do this, why not engineering students in IITs, NITs, and top colleges in our country can also do that? All they need is have to focus, put their mind and heart into it, learn, and that is what is missing.
Yeah, that's a good point, Siva. Because we had one experience because we run the fellowship program, right? And we selected the fellows after several process, 3 to 4 testing process, and one IIT, and I don't want to name him. So he cleared all those 4 steps, and he was selected as a fellow. But he didn't join the program, and the reason he gave was he was not confident whether he can do this program. Okay, so being an IITian, and after IIT he had around 6-7 years experience, and he's not confident. He also himself think the AI is more into research and deep, and he was not confident, and he was saying, I don't know whether I can do this or not. So yes, if an IITian with an experience can say that, I can understand who is still in college, BE, BTech, or coming out of college can have this mental block. There is I should say there is a kind of hype thing going on where many institution has come up and pushing AI and ML programs to bring everyone up. And although there is some money making thing happening, but there is a reality that there is a lot of jobs are created, and the industries cannot meet with the required skill set. So there is a big imbalance going on between the number of jobs and the number of skills available, right? So that being, I have to accept what you said, and particularly in tier 2 regions, it should be the, we should scale that up. What you have said, right? And yeah, now I would like to put the question to Malay here, or even Tanmay, anyone can take this. So in this entire data science umbrella, where it starts from analytics moving to modeling, machine learning, and then going to implementing the modeling and coming to the insights or automation. So where do we stand right now? Where the industry is standing right now? Are we still in the initial stage of analytics part? For an example, are we still in the data wrangling and seeing the exploratory data, the very beginning of the data? Or are we there to move into machine learning, deep learning, and further on? Malay, can you explain what are the differences here? How an industry look at a team, data science team, um, uh, to differentiate between different roles and where to start and where to go? How you look at in the industry perspective? Because you are hiring, you are extremely hiring. So
yeah. So way I would put it is like, different industries are at different maturity level, right? Like, let's say, like, if you take high tech industries, right? Like, for example, startups like, Zoom, Tanmay gave an example, right? Zoom is actually pretty cool. I mean, like, when you actually talk with mute, it could actually identify that you're talking, and it will ask you to unmute, right? So things of that nature, right? High tech industry is like, that's what I qualify as high tech industries, right? Startups and stuff like that. They are very advanced in, like, the adoption of these technologies and stuff like that. Then there are traditional industries, right? The behemoth, the giants, right? Like, the banking, financial services, and stuff like that. They're just warming up to that idea of, like, using machine learning and some of these stuff, right? At the end of the day, it is decision making, right? Or, like, helping them to do certain things a little faster. Okay. That's the way I would put it. There are two kinds of problems. I mean, like, the way I would like, generally categorize data science or machine learning problems is one, life or death. Okay. Anytime you have to deal with life or death, you go with statistical models. You don't go with machine learning, so that's being a black box. Okay. The reason is you need interpretable models, and you need to have a confidence interval and all those things. That's why if you look at, like, drug approvals and all those things, Vimal, which you are very familiar with, right? That generally goes for statistical modeling techniques. Okay. You need to exactly prove why it worked, and, like, and with a good confidence intervals and stuff like that. But then there are other kinds of problems which are more of process improvements problems. When I call it process improvement, what it means is, hey, I was traditionally doing this work this way. Is there a better way for me to do it? Okay. It's an efficiency game. It's an optimization game, right? That is where machine learning fits right there, right? And so for the efficiency or optimization games, industries are starting to warm up more and more to the idea of machine learning. Okay. Banking and financial services, you actually see a lot of virtual assistants coming up nowadays, right? Like, which are actually enabled through like some form of deep learning. When I call it deep learning, it's not end to end. Like, generally intent entities and extra action, the intent part and entity part, like, that's done through deep learning. Okay. So there are things that are being done that way, right? And certain aspects of, let's say, like, Tanmay gave an example of, like, outside energy being, like, using documents mining and stuff like that, right? Those kind of stuff, question and answering, like, or, like, efficient search of documents, like, not only based on let's say, like, your keywords, but, like, understanding the context of what you're asking, right? And searching for things, right? That's being done, like, more and more. Okay. So it's a wide spectrum, right? I think Gartner actually puts it really well, right? There are some analytics vendors, then they put them as cool vendors, right? If you look at that, for sometimes it looks very confusing to users generally, but the spectrum is very well laid out, right? So at the end of the day, when you're talking about decision making, you need people for analytics, doing analytics, right? You can't replace reports assets and say, like, rip and replace reports and say, no, that is not the way it's going to be working, right? But I mean, there are ways to actually even enhance that. That's something, like, which we guys are doing, right? Like, one, putting like, the traditional reporting. Can you have conversation with your data, right? Exposing those dashboards and everything as a virtual assistant, right? Where you can actually chat with it, right? So there are adoptions, like, which are coming in underneath, which are without even us knowing that it is coming up. That's what the industries are actually doing more and more, right? So the way it's going to happen going forward is, like, you won't see AI being talked as, like, as a big thing. That's what I envision to happen. it is going to be like, as good as any feature that is being enabled as part of the core product. It's not going to stand out. It shouldn't stand out technically, right? You have to solve a problem. You have to solve a business problem. You have to solve it effectively. And the solving effectively, if it could be done using AI, that's where like application would start coming in.
Okay, good. So still we are in the analytics stage, if you what I'm hearing, and we are slowly moving into the ML.
So,
okay.
Yeah, the one aspect, right, what is actually accelerating certain industries right now is adoption of cloud. Okay. It's like traditionally, like, for you to do all the same, compute was a big issue, right? Like, let's say if you're going to go and ask permission or like, get an approval from a CFO on a CapEx budget, like, and which I have to bargain with my CFO, right? I have to be nice to him, take him out for lunch and stuff like that, right? For compute. And generally there'll be a question, why can't you go to cloud? Like, I don't want to rent a space. Like, I don't want to put all these machines here and stuff like that. With cloud, with OpEx model, it's actually getting adopted a lot faster, right? It's actually accelerating it a lot faster than what I thought initially. Okay. So, but still we are in analytics phase. It's not, I wouldn't say like, hey, like, the adoption is really, really wide yet. There are use cases which you are seeing, which we are seeing, at least I'm seeing, right? Like, more and more getting things in, but still, like, certain decisions are through analytics and very minor part of decisions are done through machine learning, but it's going to get replaced more and more.
Okay, got
it. Yeah, sorry to interrupt here, but actually to add on that, I do completely agree with you there. In fact, I forgot exactly where the source was. It's either HBR or Gartner. They conducted a survey, and out of all the companies that they surveyed that wanted to implement machine learning in their pipeline, only 4% had actually gone ahead and done it so far. So there's still a huge majority of companies that have not switched to leveraging newer kinds of machine learning AI technologies that are still on sort of the analytics stage, I guess you could put that sort of analogy. But still, there are going to be lots of companies that are going to shift over to this in the next few years because another survey, again, by HBR Gartner, said that over 72% of those companies actually voted machine learning as the most disruptive technology out there today. Right. So, and that's, if you were to take a look at the other technologies like cloud and blockchain, cloud is 13% and blockchain is 7%. So, I mean, and definitely cloud is one of those technologies that, as Malai mentioned, also helps drive the growth of other technologies like machine learning, because up until a few years ago, if you wanted to do machine learning and get that compute power, it would be really difficult. Now you can use a cloud provider like Nimbix and instantly get, a bare metal server running in the time that it takes to get a virtual server up. So they've got some really interesting stuff going on there. And while we're still technically in sort of the early phases, it's going to be growing exponentially in the future.
Yeah, I understand that, Tanmay, but I want to put one more question here because everyone has started learning machine learning, algorithms and everything. But this auto ML is coming in now, right? So that's kind of another thing. I don't know, Mala, if you are there in that area, or I think H2O is there, SRK is fully into that.
Yeah. So, go ahead, Mala. I don't want to interrupt you.
So I want to know, okay, so everyone are learning algorithms and everyone are learning machine learning. What happens if an auto ML comes in, and why do we need to learn ML if an auto ML can do that? So it's just a drag and drop methodology or a thing that is sufficient, right? So why do we need this?
Okay. So Tanmay, do you want to go first or do you want me to go first?
I'm completely fine. I can go first if you want me to, or you can. You
go ahead. Like, I'll reserve my thing at the end. Yeah.
Sure, no problem. I guess I'll go first then. So a lot of people have actually asked me this question in the past. Will machine learning replace data scientists or machine learning engineers? And my answer is always no. So if you take a look at what AutoML does, right? If you take a look at all the different use cases for machine learning, for example, what Disney does or what Urban Outfitters does, what they do is they take a picture, for example, some kind of dress, and they try and classify it into some sort of category and say, hey, go to this aisle and you'll take a look at more dresses like this one. That is a very narrow use case. And there's a very good percentage of companies or problems that could be solved with that specific kind of use case. But there's also a very big majority of problems that simply cannot be solved with a kind of AutoML mechanism. Now, if you take a look at what AutoML does, it has one problem, say image recognition, And instead of, just training a neural network to do image recognition, you're training a neural network to find neural network architectures that are trained to do image recognition. Now, what you're not doing is you're not training a machine learning algorithm to generate a neural network architecture to do anything. You are training it specifically for the task of image recognition. Okay, it can be any data set, but it's only limited to image recognition. You could create a separate model for translation or for natural language classification, which is what Google has done now, and they're making it available. But for all the different use cases that people want to implement with machine learning, AutoML simply won't be sufficient. They can help augment techniques that researchers do. Like, for example, evolutionary algorithms could be used for hyperparameter optimization, but they will not replace them altogether. So, for example, there's a project that, as you know, Dr. Vimla, I'm working on around understanding electroencephalogram through machine learning algorithms on mobile devices. Now, for this, there are a few really unique things that need to be done. I need to make sure that it's a very, very small neural network to run directly on a mobile device in real time. I need to make sure that I'm able to analyze electroencephalogram over time very, very accurately. I need to make sure I'm not making the wrong decisions, or else it's just going to be spewing out random intents. So in order to make sure that's all done, because I have not ever trained any other machine learning system to do this, there cannot be a full AutoML system for this. I still need to go in the back end and create a new kind of architecture with my human creativity that can solve this problem. That's something that the computer won't be able to do, and as far as I can see, will never be able to do. So AutoML algorithms, some certain components of them can help out data scientists in the sort of long tail of machine learning use cases, but there will be quite a few use cases that could simply use AutoML and be done with it. Then again, there's going to be a very, very big majority of personalized machine learning applications that simply won't be able to benefit from the complete suite of AutoML. But Malai, you go ahead.
Yeah.
Okay. Spot on, Tanmay. Okay. So the way I would classify AutoML, there are multiple things, right? There is structured data where you have to deal with, right? Then there's unstructured data. Okay. If you look at what a data scientist or somebody does is, right, they bring their intuition, they bring their subject matter knowledge, talking to business and the business analysts and others, right? And bring that kind of perspective into actually something called as feature engineering. Okay. There's certain aspect of feature engineering that could be automated, right? If you look at there are different varieties of AutoML that is out there, right? Google has their own version, H2O obviously has their own version. Okay, Amazon has their own version, right? And all honesty, we are working on our own version too. Okay, we think we want the different aspects of it, so we are bringing our own flavor to it, right? But the thing, what is the problem here is the parameter space. Let's just take structured data, right? Forget about neural network deep learning for a second. That's even a bigger problem from architecture perspective, right? Let's just take structured data as an example, right? Where I could solve this problem with a shallow machine learning algorithm. For example, random forest or XGBoost, or let me throw a logistic regression in it and all those things, right? So the feature engineering part, there's one section, which you have to actually do certain things. Let's say how you handle categorical variables. The permutation combinations and how you could handle a categorical variable itself is huge. Okay, you can't run through every combination that is out there. Okay, so that kind of compute is let's say not available right now, or maybe available through a quantum computer perspective. That's for a later period, right? But running these combinations out, is very, very hard. Okay, so that's feature engineering, right? And then you get into hyperparameter optimization. Hyperparameter optimization, what you can do is probably you can approach it using a Bayesian methodology, right? Conditional probability. You could put things in a perspective where, right, you don't need to try every permutation combination out there, but you could control certain aspects of it. But even this is not going to replace a data scientist. Okay, what it's going to do is augment the pipeline, the dull monotonous work that is being done, right? Every time I give somebody something, a data scientist, a problem, what happens is they load the data, they do descriptive statistics on it, then they do imputation for missing values, then they go through the feature engineering process, right? Categorical variables, some of the things being handled in certain way. Let's for example, a state or a city or a zip code or whatever that may be, will be handled in a certain way. Those are the things that usually is being done. But there are some derived features that we add, right? As part of it, that comes from a data scientist intuition or the thing. That's the dark art, right? If you look at Kaggle, if you look at SRK, for example, the reason why SRK is like so good, like, and Kaggle is his intuition on certain problems is amazing, right? I've seen him coming up with features, right? That's actually an art, right? Like, you look at it and like, and that only you could only see that, right? That aspect is still going to remain, right? So needs a little bit of math background, like, for you to go through that level of tuning, right? So that's structured data. Like, you could do certain aspects with it, like, to train a model and get it out, right? When you get into unstructured text, that's where, like, unstructured data, like text or images and stuff like that, that is even a bigger problem. The permutation combinations for you to run the parameter search is huge, right? I think Google has this platform called Vizier, right? Like, if you look at some papers, they don't publicize it, like, outside that well, but on that particular platform. But what happens is, I mean, like, if you saw the recent EHR paper that came out from them, where they were trying to predict the serious adverse event in a particular patient, like, using, they got data sets from University of San Francisco and Chicago. In that particular thing, they actually ran it on Vizier to come up with an architecture search, right? That, I mean, like, if you look at that, that's 220,000 hours of GPU usage. I mean, like, my CFO would kill me if I'm going to try something like that, right? That's not going to happen, right? Maybe, like, they're trying it on a research purpose for that particular problem, but coming up with something, it has some practical limitations out there. Okay, unless or until, like, we come up with a different approach to solve that, AutoML is not going to replace a data scientist job per se. It's going to augment. Okay, the mundane work, the dull work that, like, I would rather not do, that will get automated, and that is the case with any industry, right? So
yeah, yes, good one. Both are really spot on. But still, I have one question, very basic layman question, which I should put here, because there could be participants who are not in this domain to understand. But before I'm putting that question, I would like to give a chance to the participants who are already there to ask any questions here. So any participants joined here, if you have any questions, can please shoot your questions. Anyone?
Yeah.
Yeah, please, go ahead.
Hello everyone, this is Surajit. I'm one of the fellows here in GradValley. I had a question. We're talking about specific business cases for various domains. So I had a question about robotics versus automation. So currently, when we are studying about machine learning, the various algorithms, the form of machine learning that I see is one is the statistical analysis, and the second one is the deep learning and the programming aspect of machine learning that goes into research. I mean, more of computer vision and natural language processing. But when I come into the industry problems, it's mostly around the statistical problem solving portion. So my question was, which portions of machine learning exactly cater to the businesses? Is for fintech, it's mostly the statistical modeling. But for robotics process automation, which portion of machine learning is used to address the problems in this domain of robotics process automation?
okay,
Good, good.
Tanmay, do you want to go or do you want me to go? I just want to give an opportunity.
You let me go last time. I'll let you go this time.
Okay, cool. Thanks. So, okay, RPA is very interesting topic, right? I mean, like, now you're trying to automate most of the manual work that you do, right? Pretty much like, mimicking a clicks and all those things that you could do, right? The one aspect where I've seen people try to apply, I haven't seen it being applied yet. Okay, I'll take it with a grain of salt. Like, sometimes people claim for certain aspects, like, for marketing, for PR, for like, investors and stuff like that, right? The one part, like, where they have seen, like, or like, I've heard from people that they are applying it is using convolution neural nets to actually detect what's there in something in the screen, right? And put your clicks and everything based on that, okay? For automating certain aspects of it, right? And again, like, the reason why Google actually replaced the captcha aspect of it on aspect is it could be actually broken by a neural network, okay? So when you look at RPA per se, right, like, there are different areas that you could actually do and stuff like that, right? But one area where, like, you could apply deep learning or something like that is, like, the convolution neural net aspect of it. Actually look at that as an image to make a decision rather than, like, going rules based, right? That's what I mentioned first, like, rather than as an if else condition, like, going after it. It's a better way to actually make a decision. where to click and what to do. Yeah, that would be my take.
Good. Okay. Absolutely, I do agree with that, and I will say that I mean, I mentioned before, only 4% of companies are using machine learning technology today. So there's still only a very, very limited scope of where people are implementing machine learning technology, because even though companies are collecting a lot of data, even from, for things like, oh, someone says they can't hear. Can you hear me, Dr. Rimmel?
I can hear you, yes.
Okay. I hope
Yeah, you're clear.
Yeah.
Okay, perfect, thanks. All right, so yes, as I was mentioning, so even when it comes to RPA, there's a lot of data that companies are collecting, but the thing is, it's not organized in a way that a lot of companies can make use of it. So, for example, I was at a major oil company in Amsterdam recently, and they're an IBM partner, and they're talking about how they're collecting so much data across their company where they could do so much automation with machine learning, but they do not have it all put into one place. They do not have it all in one clean format where they can actually apply it. And even at that, though, there are still companies that are working towards enabling machine learning to automate a lot of the things that they've had to do manually. For example, power companies, when the power goes out, they've got to manually drive through all those power lines and figure out where the problem is. And even in countries like the U.S., Canada, this is really, really inefficient. In other countries where power lines may be even more inaccessible, maybe countries like India, it would be even more inefficient. And so what they're doing is they're using drones, for example, to automatically fly through over those power lines and detect where something may have gone wrong automatically to let the ground crews know so they know where to go. So there are lots of companies that are starting to work towards implementing machine learning. And again, this is something that without machine learning would have been, I wouldn't say impossible, but would have been very, very difficult or inaccurate to implement. Because understanding visual data, for example, is something that without machine learning technology was extremely difficult. Of course, there was manual feature engineering you could do, but it was never as accurate as modern convolutional neural networks or new techniques are. So what I will say is that there are companies working towards it, but as companies figure out how exactly they're going to be making sense of and centralizing all their data and actually starting to make sense of it, that's when we're going to really start to see it grow.
Good. Thank you, Tanmay and Malay. I'm coming back to, is there any other question from audience? I'm sorry. Okay. So anytime, please raise or put, if you have questions, just put a text and I can open that up. So I'm coming back to the AutoML question. So even before discussing AutoML, I have one very layman question. Do we need mathematics to learn machine learning?
Okay. So Tanmay, you want to go first on this one? Then I'll go.
Sure. Sounds good.
Okay.
Now, a lot of people ask me this, whenever I talk about machine learning, do I need to know the math behind machine learning before I start? And I would say that it is very helpful to understand the mathematics behind machine learning. So, a lot of people, would just want to dive straight into the architecture using APIs like Watson or Keras to just put layers together. But you've got to realize that once you understand the mathematics that go behind the actual machine learning algorithms or deep learning algorithms you're using, you get a much better sense of what it can and cannot do. You get a much more intuitive sort of layout in your mind of what they're capable of. So, for example, when I started learning about machine learning, the first time I'd ever heard of machine learning technology was when I stumbled upon Watson playing Jeopardy. And so, of course, I didn't dive straight into the math, but when I wanted to create my own custom implementations of machine learning, I didn't start off with TensorFlow or Keras. I started off with the bare bone math behind backpropagation. I actually wrote down the math behind backpropagation onto a piece of paper and went through it, 2 or 3 times to understand how exactly it worked. And it gave me a good intuitive sense of how neural networks learn. And that helped me to develop even better architectures, which of course I wouldn't be able to do if it weren't for me learning that. Now, in the majority of use cases, I'd say like 70%, maybe even 80%, you probably won't use those low-level mathematics, because there are already APIs that would do it for you. If you're implementing a simple convolutional neural network and you've got to implement that math, you're probably doing something wrong because there's already someone that's probably done it more efficiently than you, because TensorFlow, for example, is open source and has been contributed to by thousands of people over many years now. So really, the majority of that math that you're going to learn will be used to help you understand what goes behind this technology. Will probably not be used in your day-to-day life, but when it does get used, it's going to be very helpful, and even then, it's going to give you a good idea of how things work. But Malai, you go ahead.
So I get this question so often. Go ahead, Vimal. So
Okay, I'll put one question connected to this. Maybe you can answer both. So, if someone is not good in math, okay, do you think AutoML will be helpful for them?
I can answer. Let me tackle the math question, and then I'll get into that part, right? Okay. So so I get asked this question also, like, so often, right? For me, I went through the hard way. Like, I got into machine learning little earlier than people. I mean, like, I started in this field around 2012 time frame. Okay, way before MOOCs and other things. Actually, I was probably one of the first ones to take the Coursera intro into machine learning course by Andrew Wing. Okay, as soon as Coursera was there, like, I think I took the course 2012 2013 time frame, I believe, right? So for me, right, like, again, I went through the hard way of learning the math and stuff like that. But what I'm seeing more and more with people, right, we are in a generation where we are looking at instant gratification. At least, like, when I'm looking at millennials, Tanmay, no offense to you, right? But, like, there are others whom I see, right? Like, there are more of instant gratification. I am doing something, I want to see results, right? If I don't see results, like, I'm not interested in doing it anymore, right? So when we are dealing with a culture, like, of that nature, the first thing what I do is to get them interested. I generally tell them, forget about the math, right? Just start, right? Play with the APIs. Like, you don't need to custom implement everything to begin with. Okay, like, use Keras. I mean, like, I'm part of Keras community from the beginning. I mean, like, in fact, there are a lot of Keras contributed in my lab, like, who does open source contribution, even into TensorFlow, actually. Okay, so when we like, I'll just say, like, start with Keras, right? It's like building blocks, like, put things together, see how it works. Like, once you figure out that it works, right, then you want to get into the details of it. The way we would generally classify that is, like, we have a lot of fun in the lab, right? Research lab. We call that Siraj level, right? We call that, like, Jan LeCun level, and then we call it Jeff Intense level. Okay, Siraj level is actually very famous. I mean, like, his videos are cult, right? Like, I actually like his videos. I watch it sometimes, right? Jan LeCun, obviously, like, one of the founders of convolution neural networks, right? Like, Lenet is extremely famous, like, chief scientist at Facebook. Then Jeff Hinton, father of deep learning, okay, the guy who founded backpropagation. Okay, so there are different levels of math you probably will deal with, right? So beginning with, stay with Siraj level, right? Like, just to get your idea in, like, try it out, like, forget about the math and stuff like that. But you could probably get it to 70-80% accuracy, right? But if you want to get it to 82, 83, 84, 85, right, that is where you start to know the math. Okay, the reason why I'm saying that is the difference between Usain Bolt and the guy who finished the next to him. No, probably nobody remembers that guy, right? The second guy. So that is the difference, right? When you want to get that ounce of accuracy improvement, you need to have the math. Again, when you're saying math, I mean, like, no, it's not that, we actually, I mean, if I remember well, like, I had linear algebra in 11th or 12th grade in high school, right? Like, I went through these things, right? Like, we go through algebra, we go through trigonometry, we go through, like, probability and statistics, we go through linear algebra. These are the math that is actually used underneath. I mean, like, calculus, right? These are the math that is used underneath. It is not, like, extremely complicated or anything, right? I would still suggest them to actually go through the math and take Khan Academy. You don't need to do anything fancy, right? Just go through Khan Academy. I mean, like, again, there are so many MOOCs available right now. I mean, like, if you want to learn, you could learn the math really, really well. Learning the math helps you to actually solidify your foundation and make you understand why certain things work. Okay. Sometimes the problem with not understanding the math is, like, you don't know how to explain it to folks, right? You don't usually use math to explain, but, like, if you want to explain it in a confident way, you need to understand how the inner workings of it and explain it in a simple way, right? Richard Feynman says, right, like, if you can't explain it to a 5-year-old, you didn't understand it well. That's my philosophy too, right? But you have to understand the math for it, like, at a level, so that at the end of the day, whatever model you are building, business or, like, anybody who's a decision maker has to use it, right? And the question always will come, like, why should I trust your model or classifier or whatever that is, right? At that point, like, you need to have that math foundation to actually go and explain why certain things work certain way. Like, what is the intricacies of it, right? That is where it will play a role. Okay, getting it up and running, probably you don't need math. I mean, like, a lot of primitives have been already built, right? Like, a lot of open sources out there. Like, just get it up and running. But, like, to improve further on anything on that, like, math is needed, right? Now getting to a question on AutoML. Okay, AutoML is fascinating, right? That way, without doing math, will AutoML work? I mean, like, you could, it's as good as using an API, right? You throw something at it, it comes with an output. You never know why that output has come, right? Number one. Second, right? Like, if you want to explain it to somebody, again, you need to know. See, the problem sometimes is, right, smart people hide behind math. They say, like, they treat algorithms as God, right? Which is actually wrong. I mean, we work heavily on interpretability of deep learning models, right? We want to actually open it up and show, like, why certain decisions are being made. Okay, so if you want to explain it to folks, again, at that point, you need to get into the math aspect of it. You need to know at least the basics of like, why an algorithm, why you chose certain things. Like, even like every model or every algorithm that you use, for example, random forest or gradient boosting or logistic regression, come with some inherent assumptions, right? Naive Bayes, they come with some inherent assumptions. You need to know that assumption. If you know the math, understanding the assumptions is a lot easier. That's the way I would put it. Okay, it will help, but you still need to know the math at some part to actually help you do things better.
Yeah, in fact, I do agree with that. To add on that, there's an AutoML library that you've probably heard of. It's called Teapot. You've heard of that, right?
Not really.
No, okay. So there's this GitHub repo. It's by an organization called Epistasis Lab, and the product is called Teapot, TPOT. It's basically an AutoML library. It's really interesting. It does basically genetic algorithms to evolve pipelines in scikit-learn. It's a good library. I've used it on a few data sets, and it comes up with good results. But you can always do better as a data scientist.
Yes.
When you know the math and when you have that sense of the data and understand the actual algorithms, you can always do better than what the AutoML algorithm gives you. So it'll help. It'll give you maybe some more experience working with the technology. It'll let you understand what it can do, but it won't replace understanding the math in any way.
Good. So remember, it's 10 o'clock and what is that? I can see. Okay.
Remember, so no, there's nothing shame in actually revising your topics, right? This is a book which I recently got, okay? Mathematical notation for engineers, okay? Which is kind of cool. Like, when I read papers and stuff like that, I get lost in the math too, right? So I go through, like, I revise. So that book is right next to me right now.
I wish Malay, most of our engineers do this.
No, you should see my library, man. It's completely math.
Okay, so we are getting closer to our time. So I want to direct the questions in another aspect now. Shiva is also here. So Malay, you are hiring for your Sama technologies, and but you are hiring at the research quality, right? The research level.
Yeah.
You are hiring at for the research, and Tanmay is also working on research. But in general, what is your expectation? Let's forget the research level, okay? That is, what is your general expectation from the candidates you expect for a minimal entry into data science or artificial or machine learning, wherever it is? Stands.
Got it. Okay, so the first and foremost thing for me, right? They should have an ability to code. Okay. Right. And the second thing is they should, from an attitude perspective, right? I want them to be comfortable working with uncertainty. So what I mean by that is, a lot of times you're not going to get the result what you want. Okay. I've seen researchers go into depression, right? Not even researchers, even data scientists go into depression for that reason, right? You are at a problem for 6 months and you can't get an output. There have been cases where, like, I used to work in a place, I ran a model, like, it was an Hadoop cluster, like, before GPU days, right? And like ran a model, went for an India vacation, came back, the model actually didn't work, right? So there are things, right? So the attitude actually matters, okay? How they tackle certain problems and stuff like that. Then the other aspect that I look for is like, hey, have you done any open source contribution or anything of that nature, right? Are you confident enough to open source your work, okay? If you've done some models and stuff like that. And Kaggle actually also plays some weightage in the way, like, if I'm going to hire for a data scientist per se, the generic level, right? The reason is, right, like, if you compete, like, you work on your skills, and like, if your rank is decent enough, then yeah, there is a chance for people to actually get hired that way, right? I generally don't care much for degree per se. I mean, like, I'm like, again, I know how the education system works, and I went through that too. I mean, I actually went to a really good college and stuff like that. We had, like, some really cool courses and cool professors who taught us well, but still, right? I know exactly how to beat the system. I know how to exactly pass, right? Like, study to pass. So I really don't give much weightage for, like, the marks and all those things. It's just that ability for them to do. So the way I evaluate also, I give them a problem, okay, a data set, and say, like, come back with your analysis, come back with your like, model that you built, explain me why you chose that, and stuff like that. That is a better way for me to evaluate.
Okay, great. So there is a question from Mahesh Gurumurthy. I will take this question. I have one more question, and then I will take this to the expert. So here for Siva, for you. Now, there are so many artificial intelligence or data science programs in MOOC online. Not only data science, for anything now MOOC, right? The entire education system is changing from traditional system to MOOC system, right? It is happening. It happened and it is happening. And there are other programs where, like, certain institutions are providing, where it is a blended one, where there are certain partly online and partly contact classes. And there are programs like us, like how GradValley Fellowship offers. It's completely in-house, rigorous research level. So there are 3 levels here. Now, what is your take on this? What will be your advice for anyone, as far as who want to enter into this field? Because we see still many are still in Java or that level to go and do programs from local institutions or even in MOOC. But someone who is entering into this cutting edge technology, or the future of what is happening right now. So what do you think the choice of education that one should pursue, whether it is a MOOC or it's a blended or it's an online, like a traditional classroom system? What is your take on it?
I think with technology in our hands today, almost, as you said, everything or all the things are available in the online platforms, and then courses available in various platforms. I would always suggest to start with an online course, understand the fundamentals, basics, get a hold of what the technology is all about. I think that really happens in most of the online platforms. Only if you have to go deeper into practical research aspect, you need someone to handhold you. Otherwise, 40-50% of most of the technologies could be understood and learned through all these online platforms. And I would encourage young engineers who are aspiring to build their career in AI or ML or in any technology or any platform could really make use of these programs available online by the experts across the globe in your own living room, in your own laboratory, in your own home, and then build the fundamental expertise. And then with that, they could get on to a full-time course like yours in a research lab, where they can really get hands-on, do projects, get somebody to mentor, and then get into live work. And that's where I think the career progression will happen. The starting can always happen in the platforms.
Good one. So Malay, do you think the same? So the MOOCs can give a fundamentals, and still I cannot replace a traditional system of it can provide hands-on experience?
Vimal, do you know the completion rate for MOOCs?
I heard somewhere around 4%.
13% lesser.
Okay, then I'm okay.
13, right?
13, okay.
So the thing is, MOOCs is actually cool, right? But sometimes you still need the structure to actually make it work with it. Okay. Generally, what happens is, like, people will start with MOOC, but they never finish it. I've seen that. Like, I don't know how many courses I've taken. Like, sometimes I sign up for a course and never end up finishing and stuff like that, right? So MOOCs is good, but still you need a structure. So as Shiva rightly said, right? Like, you start with MOOC, like, you get your fundamentals, you get your idea, you get your feet wet, whatever, right? Like, and then you get into a structured program where you really want to do. For me, like, this is like, hey, I want to do a test ride before actually I'm going to buy this car. Okay, test drive. That's the way I would put MOOC for now, right? there are some really good MOOCs. I mean, they've done a wonderful job. I mean, like, now I've used it so much, right? Like, per se, I don't have a traditional way of, like, I didn't, like, train in a traditional way for machine learning and stuff like that, right? I use MOOC, but, like, again, you have to be extremely dedicated and you have to be in an environment. For me, the environment where I worked gave me the structure, right? Where we had to do work. I mean, that motivated me to actually focus on it, right? Like on the MOOC to get my knowledge there and, like, try to apply and see, like, and stuff like that. So you still need the structure. Structure either can come from work or from, like, GradValley, like, can give a structure, or institutes like GradValley can give a structure of that nature, right? That is where this thing. So traditional structures will not completely get replaced. It will get disrupted though. Okay. But MOOC is also here to stay. Traditional structures are also here to stay. They have to coexist, right? That balance has to be found. It's still early days for it.
Okay. So now this is question to Tanmay. So you are an exceptional here. So how are you learning? Okay. So you started from somewhere and you are here. Now you are into research. So how you learn? Do you use MOOC? And how you get your hands on? How are you doing?
Sure. So, I mean, as you probably know, originally I started working with machine learning technology when I was 11. I've been coding since I was 5, but machine learning technology when I was 11, when I stumbled upon Watson playing Jeopardy. So that was originally how I figured out, what machine learning technology is, and immediately I was fascinated. So I initially started learning about machine learning, not by the actual technology, but by, well, the application. So I would actually use more different Watson APIs to create simple applications. Like, for example, this one time I took the entire Gmail frequently asked questions page, fed that into the Watson API so you could ask it a natural language question like, what do I do if I forgot my username? And it would reply back to you with the correct article or set of steps to solve your issue. So what I will say is that I originally started off by learning how the Watson APIs work and what machine learning technology that powered them was actually capable of. And then from there, I was so intrigued that I wanted to find out more myself. And so I stumbled upon more advanced deep learning technology, neural networks. And so I wanted to figure out how neural networks work. So as I mentioned before, I would actually go ahead and find the absolute simplest bare-bone paper I could find on how backpropagation works. And I went ahead and took the simple, I think 5-step formula it gave, and I wrote that down on a piece of paper, drew out a neural network, and just trained it on paper from scratch, just 2 or 3 steps. And that helped me get an understanding of how neural networks work. From there, things progressed. I learned about, different kinds of architectures, convolutional, recurrent neural networks. And then I learned about, the different kinds of architectures that exist, resonance, inception, that kind of stuff. And from there, I've been really learning by example. Right? Like, whenever I think of a new idea, a new application, like, for example, electroencephalogram understanding or completely unstructured conversations, all this stuff. Whenever I think of one of these new ideas, it's always me trying to think of, okay, how do I solve this problem? Figuring out new kinds of architectures, new kinds of things that have just come out recently. And that's really the way I learn, by example, by implementation, which is the way that I love to learn mostly. Of course, there are some cases where I do love to learn sort of from different courses. Like, for example, I'm currently reading, the deep learning book by Joshua Bengio, which you've probably heard of or seen before. So these are the kinds of things that I love learning from, mainly implementation example, but also through different resources like different books, different online resources. Like, for example, there's some great YouTube channels that help me stay up to date. Like, for example, there's the 2-Minute Papers YouTube channel. These kinds of things really do help out.
Good. Thank you. So there is one last question to Siva. I will go there, but before that, can someone take the question from Mahesh Gurumurthy here in the text? When you talk about RPA for decision making, if you can read this and if you can, someone take that question. So the question is, when you talk about RPA for decision making, what is the best application to be used? For instance, we are playing with huge data for reporting using a tool Tableau, but there are a lot of constraints via table size, maximum data limit, pictorial information. Anyone?
Yeah, maybe I'll take it,
Okay.
Vimal. Okay, so this does not traditionally fall under an RPA category, right? Like, you are trying to portray something to, let's say, decision makers on for them, help them to make a decision. Okay, RPA is traditionally used for automating certain things that are done manually, right? So think of a different paradigm, right? I mean, and this stuff that I talked about a little bit earlier, where we have a product around this line, or it's embedded within our product on this side, where we have this concept called, can you have conversation with your data, or conversational experience with your data, right? Can you ask a natural language question, can that be converted to a SQL, right? An executor, and can you get the results back? There are a lot of constraints in it. It's not as simple as this thing. The reason is, right, you can't convert every natural language into SQL, number one, right? The second thing is, again, the compute infrastructure also has to scale, right, for that. If you want to look at something of that nature, try Google Sheets. Go open Google Sheets, okay? There's a paper from Google Brain called Analyza, okay? That is the paper, right? And they have implemented that version of paper in Google Sheets, actually. It's a feature that is available. You could actually, yeah.
Yeah. So, hi everyone, good morning.
Go ahead, Magesh.
Okay.
Magesh? Yeah, go ahead.
Good morning. So, my question is, we are doing lots of automation in my current organization for decision making, but whenever I discuss with the Tableau developer, there is, the person is saying that there is a constraint while developing the particular field, or particular showing the particular information to the leaders. So it is becoming very difficult to take the decision process whenever we see the data. So, I would like to know, is there any other tool apart from Tableau to develop or to showcase the correct data to the leadership, so that we can take appropriate actions and we can do the predictive analysis in advance, and then go ahead. We'll see the go forward plan for the particular project execution. That was my question.
Yeah, maybe try looking at Answer Rocket. Okay, they have something similar. ThoughtSpot is another product that is actually on similar lines. All right. If you're looking at a product to buy per se and use, right? ThoughtSpot actually got around $300 million in funding. They're working on the similar areas, right? They're looking at a drastically new approach to actually solve it. Answer Rocket is more recent. ThoughtSpot is more matured from a product perspective. Maybe you want to take a look at them on this, right?
Okay, good. So the last, we are coming to the last part, and I have one question to each of you, so that and we can close here.
Yeah, so, because what we are doing in current organization is we will give the data which has 2 MB, 3 MB. So that's the reason.
No, yeah. Take a look at that. And maybe ping me offline. I don't want to drag this conversation out here, right? I think that would be a better way to do it. Okay.
Magesh, I can give you the Malay's connection. You can get him in LinkedIn, but still I can give you the connection. Okay. So the last question. There are beginners who are trying to enter into the data science area, and there are who are experienced, who like what Mahesh is discussing here. So who are experienced in where they are connecting with leadership, and who are entering into the data science, and who are in the mid-level career, and there are someone in the late level at the CEO levels. So let's not go into the CEO level, CXO levels. For the mid-level career and for the beginners, what would be your advice to where to start and how to move forward? Just doesn't need to be a long one, but just one line at what you can say. I can start with Siva here, because you are handling with a lot of helping anyone in career change and in leadership level. So what do you think? Let's forget data science. For anything, for anything, what will be your advice? How you want them to take someone in career change and someone who is coming out of college and being a beginner? Fresh.
I would always look at one quality that one should possess to build a long-term meaningful career in any domain is consistency. Malay said, people get onto online courses out of enthusiasm, enroll, and then you attend 2 or 3 programs and then you drop off. or out of interest, since everybody talks about AI, ML, looks very fancy. I want to be in this domain, then get inside, and then it's not your place, and that's a big challenge. So you have to really do an introspection, understand, is this going to be your life and future, and is this the domain you want to be really build? If not for a very long term, at least you should have a very clear short and medium term aspirations anchored in that domain. And if you have that aspiration anchored, and then with that, if you consistently work, I think any domain has to grow.
Great. Thank you, Siva. Coming to Tanmay, for beginners and for who is in the career change.
Sure. So, I mean, it's very, very hard to condense how exactly I believe people should get into data science into one sentence. But really what I would say is from a very, very beginner standpoint to getting into the field of data science and machine learning technology, it's important to do two things. First of all, I do always say that whenever you're getting into machine learning technology, you should be treating it as the next sort of level in a way of technology that you develop with. So learning how to program, making sure that you're actually passionate about programming and using technology in the first place, that's very, very important. And then once you've gotten that in place, once you understand coding, programming in depth, understand the actual technology, from there you can go over to that next level of machine learning technology through resources I'd recommend, like, for example, different APIs. Like, for example, as Malai was mentioning, you don't need to jump straight into the math. You can jump straight into different APIs like Keras or even Watson. Take a look at an ultra simple overview of how machine learning works, get in through there, and then advance through different examples using different deep learning APIs or more advanced ones like TensorFlow, and then try to understand the actual mathematics to go behind it. So that's sort of the progression that I'd say you should take, but of course it's hard to condense all of that, I believe, into one single sentence.
Good, thank you. And Malai?
Oh, okay. So I don't think I'll be able to condense in a single sentence, but I'll attempt, right? The one aspect that Shiva addressed, right, like the consistency and stuff like that. I would like to put one disclaimer here, right, on that. I mean, it looks very sexy from outside and all those things, right? Which it is sexy, right? Let's accept that fact. But if you want to make money to get into this field, probably you're choosing the wrong field. Okay. The only reason why I'm saying that is, right, like now the amount of effort actually you have to put in to stay up to date in this field is actually a lot. Okay. There's a passion that is needed, like, to be in this field, and like, and probably the amount of effort you're putting in this, right, like, you would probably make more money trying something else. There was a very funny question in one of those meetups that I attended with Ian, right? Gans, the author for Gans, right? You were saying I mean, obviously with Gans, the next question that comes up is, hey, can I generate a currency note that which looks very similar, right? And Ian jokingly said, like, if you're so good using deep learning to actually generate a currency note, probably you would get paid better than trying to fake it, right? So that's the kind of thing, right? Like, you have to, I mean, like, you need a passion to actually get into this field. That's one, the attitude aspect of it, right? The second thing for beginners is actually rather, I would say, easier to actually get into this field. Okay. The problem is where, like, you have a mid-career or like, rather experienced people trying to change domain, right? The beginners, right, you could come straight up and say, like, hey, like, this is my open source contribution, this is what it is, right? This is what I want to do. I mean, like, and it's a very clear shot. The reason is our expectations is also very low. Their expectations is low and our expectation is also very low, right? When they get in, right? I mean, you usually give them, let's say, a little bit of time for them to actually get settled and deliver, right? But when you are hiring, like, mid-level or like, like a little bit of a senior person, what happens is they come with that expectation. They come with that expectation that they want salary, right? Higher end of spectrum, right? And the second aspect is, right, and you also expect them to do certain things, right? This is where the disconnect between the executive management to middle to this particular thing will all start happening, right? So it's very tricky, right? In those cases, again, my advice for people who are trying to change it mid-career and stuff like that is get a couple of commits or pull requests into any open source, right? That adds tons of value to your profile. Okay. Not a lot of open source contributors in the world. I mean, like, if you look at it, it's being run by a few. The entire cloud computing thing was probably started by Linus Torvalds, right? Without Linux, I don't think cloud would have been anywhere. Okay. But the open source contribution is the key, right? That's what I would put it. Open source contribution, Kaggle, I mean, like, blogs, maybe start writing blogs. And if you're confident enough to get on stage and talk, that gives you a lot of brownie points. Okay, mid-career point. Again, go through your programming. Like, you need to be good in programming. You can't be hands-off and say, like, hey, I'm a manager, I'm not going to program. That doesn't work anymore, at least not in product companies. I mean, I still code. Okay, probably, like, my experience is the same as Tanmai's age, right? Which is probably true. Okay, so that's how I would put it. And one aspect is approach it as software 2.0, as Tanmay said, right? This is software 2.0, right? You could solve problems in traditional way, but you could solve it better and more efficiently using this. I mean, software 2.0 is not my I didn't coin the term. Andrei Karpathy coined the term, director of self-driving car in Tesla. Okay, so that team, right? Like, he coined the term. So approach it as software 2.0. That's the way I would put it.
Thank you, Malay. I got 2 points from here, and I it's a well said too. Passion, because even for a fellowship program, that's how we advertise. You don't need anything; you just need a passion to do it. So if you have a passion, the learning becomes easier. Okay, so you will drive forward to learn. Number one, it doesn't need to be data science for any field. You need passion. Number one, and second thing, for mid-level who entry, you come from mid-level experience, but still you are a beginner here. So that understanding should be there. Okay, so that's where the disconnect happened between the salary expectations and the delivery, what you are going to deliver. You are still a beginner for this field, not for data science. Anywhere, if you are changing career, you are a beginner for that particular job, right? So this understanding is missing. This is where I think like people like Siva should help, who is counseling on someone on career change, right? So that's a very well said point, Malay. I take that. And
Vimal, to add it, right, you should put it as years of relevant experience, not years of experience.
Yes, that's right.
Okay.
That's right. Yeah. So thank you all. Thank you, Malay, from joining us in the Friday evening. And Tanmay, it's midnight already in East Coast. And and for Siva, morning Saturday in India, it's a working day. You have many commitments, and you are here joining this webinar. So thank you, everyone, and my sincere apologies for all the registrants who registered, but we couldn't send the link, and we missed all those registrants in this webinar. But we will post this video link in YouTube, and we will upload and share it in LinkedIn. So who all missed it can see this video. But at the same time, for the next webinar series, we will ensure, although it is not our problem, but we take the responsibility for missing those registrants. So please join us on the next webinar, and thank you everyone for your time. Thank you, Malay. Thank you, Tanmay, and thank you.
Thank you.